Okay, so we have a roller coaster of 500 kilograms moving at a speed of 20 meters per second at point A here. We want to find the force exerted by the track. So here, if we draw the roller coaster there, the resultant force has to be towards the center of the circle. And this is going to be provided mainly by the normal reaction force. But of course we have weight acting downwards. But notice how I've drawn the purple arrow bigger. The reason for that is because the normal reaction force must be bigger to create that resultant force upwards. So the equation at that point A is going to be the reaction force, which is bigger, minus the weight, will equal the centripetal force. Okay, so we want to find the R. So so we just made that the subject. So it's going to be mv squared over R plus mg. So 500 times 20 squared over 10 plus 500 times 9.81. Turns out the answer you get for that is 240.905 newtons. Okay, actually his weight and his normally is 4905 newtons. So you can see he feels like he weighs a lot more. The reaction force is a lot bigger than it normally is when he's just standing still in equilibrium. Okay, what about point B? So what's the maximum speed he should be going? He would be going at B if he's to stay on track. So like if he goes any faster, if he goes too fast at B, he will fly off the track. So we want to find that point. So at B, the equation. So normally if his what you want at B is you have the weight acting downwards. Well, the weight hasn't really changed size, but the normal reaction force is normally smaller. So at B, the equation should be mg minus the normal reaction force equals, because the weight is normally bigger, equals mv squared of R. But because he might lose, we were talking about a situation where he loses contact with the track, what's going to happen is R is going to become 0. So we can rub out the R, and it's just mg equals mv squared of R. So we're talking about when he loses contact. So m's cancel out, so you get square root, the speed is equal to square root of g times R. So if we do the maths there, square root of 9.81 times radius f, this is 15, you get a maximum speed can go as 12.13 meters per second. So if he goes faster than 12.13 meters per second here, he will lose contact with the track.